best clip energy of the last session of the day. So I'll quickly introduce myself. I'm Kuldeep Jawani. I look after the data science division at High Labs. So I'm like a startup lover. I'm like a research lover. I like researching into all new technologies, and that's why I've been working on LLMs, ontologies, like for a long time. LLMs recently, ontology earlier also. So now I got a chance to combine both of them, and this has shown me very exciting opportunities in the especially field of healthcare. So let's go through this tutorial. It would be mostly a hands-on thing, would be less of the slides. I want to guys you feel how things are looking like. So let's start with the agenda first. So if I just start, so at a high level, so I'll do less of slides, more through the notebook walkthrough. So at a high level, just talk about LLMs ontologies, right? Just a high picture what they are. There's so much variety out there. Just want to make sure we have all the right things before we start. And then I'll quickly basically show you some real examples. My idea is to actually walk you through what things are actually happening. So you must have heard lots of things, right? These LLMs are doing great, like especially the ChatGPT ones. And then new things are coming in, they're evolving with time, they're growing, getting bigger, and getting more, I would say, useful. So I'll go through these topics that I have, less of theory, more of, I would say, interesting. So this is like a very mini version of the agenda. The real one I'll show you from the notebook. That will be the main agenda of the tutorial today. So I'll just share you the thought I have designed this tutorial for. So my idea is basically I'll start with the more popular topic, yeah, ChatGPT, and then talk about these I would say these generative LLMs, how they can be useful, and then probably illustrate how we can improve them, and then ultimately I'll come to the key topic of the precision NERC. That means to get to precision, what do you do? We need to do something more, right? So the initial part of talk would be, I would say, general. Even data engineers can easily go through, and there will be no data science. In the second half, we'll cover a bit of data science topics, and I would say we'll go deeper towards the end. So it will like gradually increase with time. So with this, yeah, let's start. At a high level, we talk about LLMs, right? So as we know, it's a very popular paper, the encoder-decoder theory. I don't want to go into details of that, but this is important to know some key differences. So for the very reason, I'll just quickly highlight some of the key LLMs we have, right? So they are at a high level two categories: instruction tuned and base LLMs. So as you know, the popular ones like on the right side, instruction tunes are the ChatGPT, Llama to Chat. Everyone knows about them, I think. So I don't need to speak much about them. But I wanted to spend more time on the other ones, the base LLMs, right? Because that's where I would say the key foundation data science begins and how we can capitalize on them. So they are like three categories of them: encoder only, decoder only, encoder decoder. As you see on diagram on the left side, like these were from the famous paper, like attention is all you need. And from this key idea, transformers came up, which basically had this idea of encoder, decoder, and combination of both. So what these can do? Let me first show you some of the examples of these, right? So encoder, I think BERT was the very first one to basically revolutionize the whole world. They got these BERT model, which was very effective. Until date, it is solving many key problems. Then some people basically tuned for domains like biobot medical domain, and there were many more versions. So we'll talk about them later on. Talking about decoders like GPT-3, given the OpenAI, I think that's amazing. Then Llama 2, that's open source, equal version of that. GPT-4, I think that's also the newer version. It's even larger. I'll talk about the size also later on. But to come to first encoder decoders, right? So we have like Palm 2 and T5. So besides these names, I've also given their sizes and the number of tokens, right, that they have. Like BERT has 340 million size, right? That's it. And the 3 billion tokens it was trained upon. Talk about GPT-3, it is 175 billion, right, in size, and the 300 billion tokens. Llama is new innovation. Its size is 70 billion, but it covers 2 trillion tokens. And the same leak GPT-4, they have not documented the stats for that, but said to be basically size of more than a TB and like more than 10 tokens. So that's what is just said about. We don't know the exact details. But similarly for Palm 2, again, 340 billion size and 3.6 trillion tokens. So these are all very large models. So why we want to look at these different versions? I'll just highlight the key things. The key focus on each of these things. Like the encoder is especially focused on semantic encoding, right? So which means that these natural language, right? can be somehow converted into mathematical, I would say, definitions, or as in the definition of basically computer science, data science, convert into some kind of vectors which can basically use to do many inferences, classification, conversions, many more tasks, right? That's easily possible by them. So that's like a discrete representation of information. So that's kind of one critical step. Then decoders are focused on generative AI, more about, I would say, creative generation, right? As you might have seen, like you can ask ChatGPT to write poems, it can write essays, letter recommendations, it can summarize text. So all those, I would say, creativity is all over there. And talking about encoder decoder, so they're also focused on generation, but more like an accurate generation. So like, for example, language translation, right? So there is, it's not really about creativity, it's about basically preciseness, right? You have a French sentence, you have English sentence, you want it to be correct translation, right? So their generation process has a different objective. And it's not that the one can't do tasks for others. Like, for example, even decoders can give you like embedding vectors to do semantic encoding, right? So we'll talk about all those things, but this gives like a high level picture to begin with, right? So I'll start this picture and I'll go deeper. Definitely, I'll start with ChatGPT. That's the most popular topic. And then we'll go into each of the other ones and see why do we need others and where can we use to optimize it. So before going topic, I'm talking about ontology. So there are lots of, I would say, theories around what's an ontology, and there are multiple definitions. At times people are not sure. So I just want to make sure that it's kind of easy to understand and we're kind of clear on the key idea. So I want to just basically set the definition of ontology. So it just talking about the etymology, the word came from two Greek words like onto and logia. Onto means being, logia means logical discourse. So like basically it means logical study of beings. That's an ontology. The idea being, as human beings, we see things around us, like we perceive reality. How do we perceive reality in terms of knowledge? So that knowledge comes from basically entities and relationship, basically. Like, for example, this object to that object, and every entity has like two parts, one like subject and object. To give you a very simple example, like John has location Bethesda. So that's like a subject in that there's an object, these two entities, and relationship basically has location. So that's like one simple way to store information. And in general, that's the idea of like ontology or a knowledge graph, where we can add domain knowledge, like for a given domain, like a medical domain, financial domain. So we have some concepts and relationship in that domain, right? So we can use them and also use some like an ordered formal classification like taxonomy, right? Some fixed order of things where there is no ambiguity. It's predefined and ordered. Using these two things, we can generate like a data science model, or I would say an ontology. So this is like the basis of an ontology. I'll show you a few examples of ontology. Like for example, this is like a food ontology, right? So you have different foods, ingredients, types of ingredients, right? And then food additives, so it goes on. Like one way to store knowledge. There will be more examples, like for example, it could be taxonomy, like a provider. He could be a physician, he could be a pharmacist, physician could be oncologist, cardiologist, and goes along, right? Or it could be more complex, like a medical ontology, right? Like a disease, there are types of disease, brain disease, Alzheimer's disease, they're concerned to old age people, and then maybe their symptoms, they're part of functional symptoms, basically, right? Cognitive symptoms, goes along. So medical ontologies are really complex, and people have encoded them over a large amount of time. So that's like some ontology. So we want to see how we can combine them. So high level, I'll just give you a quick comparison of LLMs and ontologies. So the key ideas of LLMs, like they can handle unstructured data, right? They're good at that. So they're good at natural language. They can understand the constructs of the language pretty well because they're trained on such large amount of data, and with such massive training, they have a good hold on that. They can generate text, right? And we have seen ChatGPT does it really well. So their linguistic concepts are pretty strong. They can capture the essence, they can summarize things, and they can do wonders over there. Where ontologies come in, they can handle structured data, right? Those graphs, which are basically predefined and non-ambiguous. So they are very precise in domain knowledge. You could also have your private domain knowledge within your company, within, let's say, particular domain, like medical domain, financial domain. It can capture very precisely information. It is good on logical reasoning, right? Because those constructs or relationship are properly defined. And definitely the key idea is a knowledge graph, right? So it can capture the knowledge in a well-defined manner. So how can we combine them? I'll just keep some key ideas and just share those ideas with you, and then actually go into code after that. So at a high level, how we can combine both of them. So like one is contextual understanding, right? So ontologies are good at knowledge and context. So we can provide context to LLMs, and this can actually help in avoiding hallucinations by LLMs. You must have known this is a common problem in LLMs. So this could be one way to help over there. Then reasoning capability. So basically, ontologies, as by definition, are designed to logical reasoning. So they can very efficiently create many queries and answer some questions based on, I would say, tangible domain knowledge. Then customizability. Like LLMs have the information in general, right? So, but these ontologies are specific to a domain. So like an industry or something, they can kind of marry both of them, and you can customize your LLMs using them. The key part again, consistency, right? So they are well defined, there's no ambiguity over there, and they can clearly resolve all ambiguous terms, but very precise relationship and definitions. So they are made to be precise and I would say disambiguous. This can also basically add a key feature called the explainability and transmissibility to LLMs, right? In general, it's very hard to know how LLMs are working, how they're answering. So with this ontology, if we tie with them, we can then know this was the context used over there, and that's why the LLM answered this question. And we can confirm the context was actually relevant to the question asked or maybe the task at hand. So with this key idea, yeah, let's just stop the slides and I would say jump to the code. So this is where I'll start with the notebook. And so there's like a list of agenda over here, if you see on the left side. So my key idea, I want to start with the main thought, right? So about LLMs, especially ChatGPT, you must have also read about papers, right? That they are so great. Why do we need anything else? Like for example, in medical domain, I especially work in healthcare area. So they are also challenging some people that do we need like even a domain specific like a LLM? Can't the massive chat GPTs take care of everything? So the question is, does LLM contain a domain knowledge by default, right? So I'll actually show you examples where they do. So they are actually powerful. I want to just first actually support the same theory that yeah, I'll show you 5 examples where they work. Then probably I'll show some of the shortcomings where that they can't do things. Then I'll talk about how we can use ontologies to cover those shortcomings, right? And then how can we use ontologies in general to use like a private knowledge or give like an context. So basically, if you have your own data in your industry, in your domain, you can convert to ontologies and use. So that will be the way to, I would say, complement these generative LLMs. But then I'll also show you scenarios where even still they can't do a job. So we need to go back more towards the data science layer or to the embeddings. So that's when the whole data science part starts. And yeah, I'll talk through as we go over there. So let's yeah, start with this. So the key part, let's quickly start. Yeah, I'm just going to import some basic things and then let's start, add some helper functions. I think that's okay. So I'll take the first example. So I just like definitely, yeah. So because I'm from healthcare domain, I'll pick most of the examples from healthcare and some general examples. So this is like a sentence from a medical text. And just to let you know, so all these sentences used there are like some, I would say, abstract sentences create by our experts. They are not related to any real person. They are just like a fabrication, but we have ensured at least the look and feel are actually how it comes in real data. So this is probably something near what comes in real data. So you see patient notes that over past 1 to 2 weeks, he has had increased chronic abdominal pain, fatigue, weakness, malaise, dark appearing urine, denies fever, chills, and all those things. So I want to give the first task to ChatGPT of finding the symptoms, like, so what are the affirmative or positive symptoms? What are the negative symptoms, right? So I can create a prompt for that. Like I can simply say, for the review text present in a sentence, please break sentence into negative and positive symptoms, right? And just let's look at the answer for this. So ChatGPT, I think if you look at the answer, does a good job. As you can see in the sentence, it says denies all these things, and it gives proper them as a list, denies all those things. And interestingly, it did not break this part because this was actually bleeding from A, B, C, and D. So it grouped them. It could understand these are a single group, so it kept the unit over there. So, and for instance, I think, yeah, if you see in the last, it initially talks about increased chronic abdominal pain, and it's correctly captured. So yeah, ChatGPT does a good job. So as you can see, without domain knowledge, it's able to actually properly separate the symptoms, right? Negative, positive. Let's look at another example. Let me scroll up. So yeah, this is like slightly complex. So people in medical language, they use lots of abbreviations. Just see this sentence. I think, yeah, you will just get mesmerized that it says male, PMH, COPD, CHF, STN, HLD. I think you must be just scratching your head. What's this all about? There's actually common lingos in medical language. And as you know, doctors are short on time. And if you look at their prescription here, writing also, they write shortly, but when they type, they type in short. So you'll find these abbreviations too often. So, and for this, so what we're going to do is kind of see how it breaks it, right? So I'll kind of ask ChatGPT to create a prompt. I'll ask it to basically expand the medical abbreviations, and let's see how does it do. So if you look at that, it says PMH, past medical history, COPD, chronic obstructive pulmonary disease, CHF, congestive heart failure, STN, hypertension, HLD, hyperlipidemia, DM, diabetes, mellitus. As you can see, these are very complex terms, and I'm telling you, these are all correct. So again, an amazing job done by ChatGPT without, I would say, being trained for medical domain specially. And as you know, like Google made their Palm 2 LLM, and they generated a mid-Palm version, right? That was more focused on medical domain. But here, they are not focused on any domain. Still, they're doing a good job. Let's look at another example. So let's look at some like a clinical history. So I think, yeah, the same sentence that we have. So I'll just use the same sentence again. And this time the prompt, I'll say, break the sentence into clinical history and present ailments. So let's see what does ChatGPT do on them. So it says it was able to find PMH is past medical history. See, this time I just gave this prompt just to break on past and current. So it could automatically figure out that PMH meant past medical history and basically assign all these to medical history, including being a current daily smoker, right? So all these were identified, and present elements CHF exaggeration. So it again did a great job, right? So as you can see, ChatGPT is doing great. So let's look a few more examples. So this is another sentence. So now I'll make a task slightly more complex, right? So this is a sentence talks about a medical test, right? So some woman with hypertension, hyperlipidemia, and worsening osteopenia, PCP ordered. PCP is basically a primary physician ordered DEXA scan 3 months ago, for which the T-score came 1.8, which confirms that the diagnosis of osteoporosis for the patient. So now let's ask ChatGPT that. Now I'll get a different question. See, now I'm saying, please tell if the patient has gone a bone mineral density test. So if you look at the string, there is no mention of this word anywhere, right? So and there is no direct mention. So let's see what does ChatGPT say for this. It says yes, the patient has done a bone mineral test, and in bracket says DEXA scan. So actually, it was able to figure out that DEXA scan and bone mineral tests are same, and because this is the context of 3 months ago, and which confirmed diagnosis of osteoporosis, right? And if I ask ChatGPT about the contact DEXA scan, like how they related, I think it can easily say that is a type of this kind is like a subtype of BMD. So see, again, amazingly, it was able to connect both of the things and kind of stitch them. Let's pick another example. So now the examples, I guess, gets a bit trickier. So let me first use the same sentence, right, for the abbreviations. And now this time, let me ask for ChatGPT to give me the codes. So this is like NERC task, right? So basically, to first identify entities, which are basically the medical entities, and then classify them into ICD-10 codes. So it's like an NERC task. So I'll ask infer the ICD-10 codes from the sentence given in the reviews text, and let's see what does this says. So the same keywords, right? It got the abbreviation right and gave me codes J449 for, let's say, COPD, CHF 5509, hypertension I10, HLD E7 8.5, and E11.9. Again, these are all correct. So this is again doing amazing. The tasks are getting complex, but it's doing good. There is a slight problem over here, I would say. So because actually, as per the laws of coding, so if I10 and I59 both are present, then there is actually a different code to be applied that's called I110, right? So let me just ask ChatGPT, right, that can it really expand it? So let me first ask a question that describe, give me a description of I110, right? So I know that this I10 is basically combined when we have both the codes. So it can actually say that, yeah, so I10 refers to hypertonic heart disease. It is applicable when the patient has diagnosed with both hypertension and heart failure, which were there. So although it had the domain knowledge, but it could not combine them, right? So it made a small mistake, but it was kind of still present in the knowledge base of that, right? So this means it lacks some context. So, but you can argue it's okay, right? You can add rule on top of that. So if you have a rule set, you can take care of these problems. Okay, but let's look at more examples. So now I'll pick more complex cases, right? So these are a sentence over here. Again, it is a sentence basically. A patient is going through some medications, right? And then it describes the condition of the patient, appears to be quite catatonic and apparently lost quite a bit of weight. So she could have an occult cancer. So on this, let me ask that identify in codes that can be used for medical coding in the sentence generated by this. So let's see what does ChatGPT gives me. So I asked for ICD-10 codes. I got a list. So just to give an FI, the first three are actually not diagnoses. These are not ICD-10 codes, these are ACT codes for drugs basically. Kind of okay, yeah, because drugs don't have ICD codes, but still gave it kind of fine, not a bigger issue. So then there's still codes. So, but the key part is uh, it also gave a code CAT1 for occult cancer, right? That's present over here. So string is over there. But if you look the sentence given by the doctor, she looks like she could have, right? So right now it is uncertain, and something that's uncertain can't be coded. So again, that's like more domain knowledge that probably we would need. That when can we code? So we need to do like an sentiment analysis, right, on this and see that kind of can we use that. And if I ask ChatGPT about what are the uncertain part in the same sentence, so it can identify that, yeah, the occult cancer is uncertain. Again, and got it right. So it can do the job, but it can't stitch those things, right? Like in previous case, it was able to get the combined code. Here, it knew this code was uncertain, but it again gave for coding, right? It could have it did not basically should not have given that. But again, this may seems like smaller problems that can be solved, but this brings questions on the consistency and precision, right? So that's why let's now see that are they really precise. So now it focus basically, yeah, till now we have soon seen the wonderful things ChatGPT can do, right? It was able to do lots of tasks like medical abbreviation, disambiguation, finding the symptoms, right? Historical and the current things. It did good at all those things. So let me now create another sentence, right? So if you just read the sentence, this is like have multiple issues. This patient it has cancer to liver, pancreas insufficiency, gut, chronic pain. There's lots of things out there, right? So I'll again ask same question, ChatGPT, to like just give me these all the quotes in the sentence, right? It gives me a list of quotes right over here. So before going to other quotes, right or wrong, let me just run the same thing again. So the same thing, I just say this time say in for all quotes from the sentence given in the same medical diagnosis sentence that I have. And now if I look at the results, I get 7 quotes, right? Earlier I got 5 quotes. If you can see, it got 2 extra quotes. So that means it is like again, if you repeat it, you'll get different answers. So that consistency is definitely not there. So can we rely upon them? Let's see. I'll maybe show you more on the other part just to make sure it is the right job. We'll ask ChatGPT to give the reference, right? So basically give your answer in the form of list and mention the words it basically picked for coding so that we know where did it make a mistake and where it was basically kind of correct. So it does give the list again. Again, see this time we got a list of 6, right? See earlier we got 5, 7, and 6. It's changing. So we kind of got this list. Now I want to kind of just let you know the accuracy of that, right? So I'll just kind of print the ground truth for this from an expert, right? So let's see, just run this code, ground truth. So this is the ground truth for this, right? So like this was the actual sentence. The one marked in the color are the words to be used. There are actually 7 quotes in this sentence, right? And this is the list, and these are the actual quotes that should have been present over there, right? Let's now just compare this with the last response given by ChatGPT and the ground truth. Let's do a simple thing. We can simply count, right, the true and false. So if you can see, like C787 present here also, right? K6081, it's a different family. 8089, it's not correct, right? So we just compare this list and this list. Count the true positives, right? I can see 4 are matching, right? So I have 4 true positive, so which are common these two, right? And basically then I have like 2 false positive and 3 false negatives. So basically I just written them over here for your ease of basically seeing them. And so precision is like 67%, recall 57%. So in general, as you can see, this is not really a good thing to have, right? A system, you won't want to use this on production, right? And especially medical domain, definitely can't, right? It has to be accurate. So in short, so what we just saw till now, that ChatGPT is amazing. It can do many amazing jobs without having specific domain knowledge. But as we go to more, I would say, complex tasks, then kind of it gets trickier, right? So what happens that it has the data sometimes, but doesn't have the context, right? So let's discuss about context understanding, right? So now I'll take like a general example just to say how the context matters, right? So I'll take a simple question, right? I think you must answer this question, like the recent movie, Oppenheimer and Barbie. So which is doing better? And I took this question because I want to see what happens when we ask out of context questions to ChatGPT. And it was trained on massive data. So I don't know what they did not train upon, but simple thing I can know that there was a cutoff data, right? September 21. So anything data created after that won't be part of them. So if I ask answer for this question, what replies basically is not possible to compare them because one is like scientist or doing physics basically, and other is a doll, right? So they're not comparable. So in short, ChatGPT does not know these two are movies, right? Because it came later on. But if I ask a similar question, and if you know, like Christopher Nolan had a same scenario like some 15 years back on another movie, which was like the Dark Knight and Mamma Mia. That time I know your Dark Knight did great over that time. So, but this question, I think ChatGPT answers pretty well, right? So that this movie performed better than Mamma Mia at box office, it grossed more money, and it knows perfectly. So what it knew, it could answer well. And if I ask a question related to the opening movie, just to see does it know or not, it can tell you what it knows about. Like for example, if I ask Christopher Nolan, what's role does it play in Oppenheimer? He's director, so there is no role for him. But ChatGPT can still say that as based on the cutoff 721, till that time it was just known that the movies are about to come, but it did not actually came in. So yes, it knows about some things, but it doesn't really able to connect them. So now how we can solve that, right? So one is basically I just copied a news article like recently, and which just talks about Barbie Oppenheimer, right? And this like piece of text. So this is where the first part comes in, right? About giving the context to LLMs. So if I just simply add this piece of text news article to ChatGPT's context, like in my prompt. So basically I can say, answer the question based on the context provided. Context is a news context given over here. And same question again, is Oppenheimer doing better than Barbie? If I just look at the response, so it says Oppenheimer collected $265 million, and in first 6 days, Barbie amassed $500 million, right, based on the date article was born, and definitely Barbie is doing better than Oppenheimer. So based on the context, yes, it was able to get the right answer. This like in context learning, right? So this is one of the ways to like kind of really tune these LLMs. We're actually modifying them. Externally, we can help them. So, but as you can see, that there would be lots of context, right? It could be like big pages. So like sometimes documents, if you keep sending them, first would be hard because there is a token limit, right? There's a 4K token limit and ChatGPTs and other LLMs also have token limits. So you won't be able to send too much context, right? Just as a text directly. So how do we concisely represent them? That's where ontology comes in, right? So let me quickly just do the same thing and talk about our tool called LangChain. This is an amazing tool out there, right? So this can do wonders and kind of actually getting ontology. So you can read about this tool. I'll just skip through right now because there are many things to cover. There's some very imports I'm going to do. Basically, it's a tool called Graph Index Creator, right? So this tool, you can just give the context and create a ontology for you. Just call this function creator, and I'll pass the same news context, the news article that I had earlier, and just get the ontology. See, it can just print tables directly, right? So it just compares that two paragraphs into these, let's say 5 lines, right? Barbie has amassed this much money, open here has collected this much money, right? And is expected to cross. So it basically kind of convert this into a set of triplets. So this I can just quickly visualize in a graph. If you just look, it's like a simple ontology, right? So with Barbie has like context, is enjoying this, has amassed this much money, is expected to cross this much money, and simple Oppenheimer, right? So this is now a brief information in succinct form, the same paragraph. Now let's ask ChatGPT again by this. This time I'll use the graph chain, right, from LangChain tool, where basically I give a graph context. Yes, option to give a graph context. So this is the news context graph we just created above. I just pass into an same question, right? So I given the context as graph and a same question. So it basically LangChain and entity size open Barmy, and it basically connects with the ontology and gets the key sentences initially says. So no, Barbie has amassed more money. So see, it could also solve the same thing uh, from information. So this is kind of see the key part over here, that we can concise information into ontologies. So be it your company data, be it your private data, domain data, if you convert to ontologies, be precise, and you can give it in succinct form, right? So so you can, that's when to create. But if you already have data in ontology form, right, let's say, then can use directly. So that's where the second power ontology comes in. So let's say we have ontology. For this example, I'll use a public ontology, right, like the Wikidata, the Wikipedia. So there's a library out there which converts, I can give access to Wikipedia, right, in Wikidata format. This is an ontology, public ontology. You can access, all of you access. So there is a, for every entity is a node. So for OpenHMR, there's a Wikipedia page entity on Wikidata. This is number for OpenHMR, right? If I just query it, I'll just get the entity ID for this, right? So what I can do, so I'll just show you, if I directly pull the ontology, right, what all I can get. So for example, I'll just pull some interesting properties from this wiki ontology, right? And so that it's kind of show the power of this, what we can do with it. So I can just print a list. So I got these properties, right? Instance of film, director, Christopher Nolan, cast member, Cillian Murphy, and the information. So just by querying the Wikidata, I got these properties. This is already a pre-built technology, right? So what I'm going to do, I'm basically, first let's quickly visualize it. As you can see, so this is information. So OpenHMR, basically, I can get the publication date as this. It was basically, there are lots of properties. Interestingly, see, we are also linking to like IMDb ID. So now this ID can open me much more information. Similarly, I have a Google Knowledge Graph ID, right? So this Google Knowledge ID will basically give you again access to many data. So we can have, let's say, our Twitter handle ID, right? So all this can again give you access to more and more knowledge sources, right? So you can keep it in them. So all these technologies can give you a plethora of knowledge. You just need to pick the right one, right? So now what I do, I basically convert this into a graph, right? And kind of ask the question to ChatGPT again with this wiki graph system, right? I want to ask new questions so that it does know about that. So when was OpenMovie released and what is it based upon? Definitely by default doesn't know about that because it is after the cutoff date. But with this graph, it again accepts entities and links with these nodes. It says yes, OpenMovie was released on July 21st, 2023 and is based upon the book American Prometheus. So see, it got it right. And with just the plus information we got from public database, right, or a public ontology. So this is like the power of ontology. We can create ontologies from private data. We can use available ontologies, public ontologies, and the right context. So the key part is just getting them right. So finding the entity, let's say the entity over here, it says entity extracted, right, over here, open here and movie. So from that, it could just connect to the key elements. So these are powerful tools. So do read about LangChain, and there are also tools like Llama Index. We can do things very easy for you. So this would be one quick way. Then there are more ways, right, to kind of access them. So I'll give you a few more examples like how we can use this. Like there's a library called LLM. So I can't run those because I think the trial version of ChatGPT kind of just gives me a rate limit, right? I can't do more than 3. So just showing the code, showing the code over here that you can do zero-shot learning, few-shot learning, something called a dynamic shot, which is like zero-shot, you don't give any data, right? Just give the labels. See, there is a training, I don't give any data, just give labels, it will do the job. And similarly, in few-shot, I give you examples, it can train upon that. Dynamic few-shot, because as you know, there is a token limit. You can't send too much data, right, for the context. So it does like a small clustering before sending it and send only unique sentences or unique information. That's like one way of kind of sending data across. So with this, I'll take kind of pause upon the capabilities of these generative AIs. And now let me focus back to the key problem, like the NERC. As I showed you earlier, that in the real world, so ChatGPT is good, but actually for doing more precise tasks, right, the accuracy goes down. As we could see, like just 15% recall, 60% latency precision on like one example. In general, it can't do a good job. But if you look at more context problems, right, like over here, especially in healthcare, the problem is even massive, right? So talk about ICD codes. ICD-9, there were like some 14K and 4K codes. ICD-10 which is being used right now, they're like 70K diagnosis, 70K procedures, like 140K codes right now. So, and that's such a large amount of data. Even the classifier won't work, right? So 140K classes can't be trained by a classifier. It would be very hard. Precision goes down, right? People try that, but couldn't work. So you have to do like in an NERC, direction of entities, and then classify into those classes. And in future, ICLM will have many more things, right? 120K codable terms, 1.6 million codable terms, so it's going to be more even complex. So the thing is, we kind of can't solve this problem just by using these generative AIs, right? Because the precision is not good over there. For creating like poems, all those things, summarizing things, because piece of art, right? There is no ground truth. So they're acceptable, right? But when you do precise tasks, you need to be precise, right? Like in a medical industry, you can't have changing things. So you do more. And this is how basically we need to go to the next level. Now from the prompts, we actually need to go to the embeddings, right? And this is where data science starts. And now let's go back to code again. How we can use the embeddings not to increase precision. So now we're going to like some kind of the math part of that. So let me start with the next part. So the embeddings. So I'll show you some examples. I'll pull some transformers from Hugging Face and also use even the ChatGPT embeddings so that we can compare them, do some basic preparing of data, right? So for this example, I created like some sentences, right? Some sentences just like people talk about general. So I'm talking about food, how people just talk about food in general, like they love sushi in restaurant, then their car driving experiences, some 7 examples of them, some physics questions, people loving quantum mechanics, then some medical sentence, right, basically. So the idea is we want to see these are like 4 topics. As you can see, these sentences are already divided into 4 categories. And now we'll use the embeddings to see, can those embeddings like differentiate these classes? So idea being, these classes internally should be intra-class, should be cohesive, inter-class, they should be separable, right? That's, if does well, then we know, yeah, we are able to use them for classification. So with this idea, so let me just do some basic preparation. I prepare a data frame, like convert the same sentence data frame. I think that's okay. So and just like convert to this like a topic and a sentence, and then prepare some of the models. So for this, I'll pull a few models for Hugging Face, like the bird base and sentence bird, BioBird for medical domain, Microsoft's PubMed bird, and a sentence version of PubMed bird, right? So along with these, I'll also use the OpenAI GPT-2. That was the public version of OpenAI before it went commercial, and the current one, like GPT 3.5 Turbo. So some piece of code to basically get these models. You can look at them later on. So basically, I'll load all these models, right, from Hugging Face. That's give some warnings, but basically I use dictionary. So I use dictionary for, let's say, the parts for them, and there's a dictionary for model and tokenizer. So tokenizer basically to convert them into tokens and units for their own models, and then use it. So with this, let's start using them. And I'll just kind of also load the GPT-2 model, right? So this is the GPT-2 XL, the open source AI model, which was available earlier. They went commercial. So I'll add some helper functions, more functions, right? These are basically to get embeddings from the encoder models, get embeddings from sentence encoder models, and basically get encoding from decoder models, right? Some helper functions, you can just look at them later on. So this is a function to get the embedding from the OpenAI's commercial model, right? So OpenAI gives you an API, right? OpenAI embeddings create, so you can basically query them. This is an online service, and you can get the embeddings for a piece of text. So what we'll do, I'll add some more helper functions, right, to do some cosine similarity to see how similar they are, right, and some business metrics computations. So I'll kind of generate embeddings, right? So the way to generate them basically, so we'll pick the sentences, right, like the one which I showed you earlier in data frame. So we'll convert them into embedding, right? So what we'll do basically, I'll call the encoder pool embedding, this one kind of embedding for the encoder models, right? And these are models I'm using right now: BERT-based, BioBERT, and MS PubMed-BERT, right? So I just get an output that a data frame, so I got more columns to data frame. So now I'll do the same thing with sentence encoder model, right? They have different function. So I need to use a get sentence encoder embedding for getting embeddings from these sentence models, right? So it gave me some warning, but yeah, gave me the output, added these factors back to data frame. So we'll do it same for the decoder, right? So with the decoder function, we'll use GPT-2 to kind of get the embeddings for them. So these also gets added to it. Now I'll have to, for the OpenAI, I need to create a list, right? So as you know, there's a rate limit on the public trial version that is 3 per minute. So definitely I can't do it. So I had to do it offline, like every minute send some 3 queries, add it to a list, and then kind of later on collect them. Like over there, basically I use this list to kind of append to the model, right? And I eventually got all of them. So now I basically have all the embeddings, right? So now we want to compute the distance metrics. That means for all the models in encoder, decoder, sentence encoders, right? So all 3 types, what we'll do distance metrics, right? So basically we'll find cosine symmetry between each of the vectors, like from all of them. And remember, these sentences are like into 4 categories. So food, car, let's say physics, and medical, 7 each. So 20 sentences. So we'll get a 28 cross 28 matrix, right, for each of them, each of the models, right? So just to show the output, so that this is matrix, I compute all of them. I'll visualize them, right? So it's easier for you to understand. So like this is for the BERT-based, right? So those sentences like 28, right? 0 to 27. So first 7, as you know, are for food, next 7 for car, next 7 for physics, next 7 for medical, right? So it's like a matrix. Diagonal is 1 because the same sentences, and we can see some similar scores over, right? And like the brighter is a good score, and the darker is like a bad score. So before commenting on them, I'll just quickly show you the graphs by all one. This is why that's a sentence BERT, right? So over here, I'll again plot just a heat map for that. I get some output. So if you see, this is giving some structure, right? So as you can see, remember there was like 7 sentence each sentence. So you'll see getting a region, right? 7 by 7, 7 by 7 by 7. So actually, sentence BERT is able to group them into categories some level. Look at these different color codings, right? So that means like the slider, that means they're more closer than the other ones. So it's distributable. So that is doing good job. Again, I'll comment more on it when we look at the other models. So first, I want to show you the other ones first, right? So this is the OpenAI one, right? The public one based on GPT-2. So if you look at here also it's doing a good job, right? So look at these squares, like 7 by 7 squares. So we are seeing that this is more brighter than the other ones. So yeah, it's good. So then again a square. The nearby is also slightly nearby, like the ranges are somewhat close, but that's okay. But we're still able to see kind of some like these 7 by 7 regions for them. Now interesting one, right? Look at the ChatGPT commercial one, like the best model we believe, because that's doing wonders. So if you look at the embedding vectors of this, so this is also similar to GPT-2 and kind of giving you these topics. So where the first topic is kind of not really easily distinguished, like they're mostly dark over here, and then others are still visible, right? So it's kind of able to differentiate bit among all of them. Let me look at some of the domain models like the biobot, right? So that is because knows a medical language, so it will kind of know more about the medical ones. So here, if you can see, it is not too good for other ones, but slightly more high numbers for the medical side, but still doesn't do a too good job, right? So let's look at medical bot, the PubMed bot basically. So here, this was trained specifically on that. So as you can see, this has a unique pattern, right? So everything else is kind of same, but for this quadrant, right, 7 by 7, this is very bright, and everything else, the rows and columns are dark. So this was focused on medical data only, and this is clearly visible that it could distinguish or differentiate medical data from everything else pretty well, but doesn't know much about food scars and physics, right? So this was what happens when you do a very specific domain model. It knows about domain, but not in general. So if we talk about the other ones, right? So the PubMed bot, right? So this also doesn't do a too good job, right? It's good on this domain, but can't do much. So now let me just connect back and see the way to it. This was like a topic modeling. So we wanted those 4 topics to be different from all of them, right? So ideally, we were expecting 7 by 7 squares for all of them, which are basically distinguishable. So now let's revisit all of these graphs quickly to see which one of these heat maps is able to define them pretty easily. And now also look at this range, right? So this is right now 1 to 0.8, right? The scores are also key factor. So this is not giving a score less than 0.8. So this also means it is not good. For example, there's a very little difference, like 0.87, 0.83. So this is like a very small thing that's happening. So it is not doing too good over here. So yeah, I'll just quickly move to the comparison part. So again, this was specific on medical, but nothing too good over here. Now look at ChatGPT, right? So ChatGPT is giving me regions. So as you know, there is the technique called RAG, the retrieve augmented basically learning. That means if you can get a user vector store, right, and kind of get the topic from that, like what does LangChain does, right? So basically LangChain first gets the topic from a question that you have and get the data from that topic. So for that, yeah, it can give topics. So basically it's able to define topics, but not the food one, right? So, and even the range 1 to 0.7. So even ChatGPT is not defining too much between all of them, right? All are getting high scores. Say even the incorrect ones are also have like score of 0.7, 0.8, right? Look at ChatGPT 2. Here it's better. See, these regions here is totally dark, and they are more brighter than the previous one, right? Because of course it was not going below 0.8, right? The other ones are even 0.7 for the non-correct ones. But here the correct ones are high, right? 0.76. The non-correct is even lower, 0.4. The band is increasing, right? So 1 to 0.3. So it is more discriminative. So GPT2 is actually better than GPT-3. Interestingly, now go back to sentence bot, right? So look at this graph. The range is 1 to something like minus 0.1. So this is very highly discriminative. And look at these scores. So kind of it is like kind of 0, -1. So it is able to define other class with a very good probability, right? Within them, it is further divided. Like it's giving a score 0.47. This not too high, but the others even lower. So the discriminative power is even higher in this. So if you talk about only the discriminative power, sentence burst has outperformed all of them, including the commercial ChatGPT and the public ChatGPT, right? So with this, this was like the first thing. So definitely for precision tasks, we need to look more into those constructs, right? And be able to differentiability. So ChatGPT can't do these things. So that's why now we'll go to more of these, I would say, other embeddings. So it shows the same thing now in like a visualization part, right? So you can visualize them. So you can also like do manifolds. You can use MDS, TSNE. And just a quick note, I'll just for the benefit of people, don't use TSNE, right? It's actually a complex algorithm. And at times the cluster size are basically, they're not meaningful. Even distance between clusters is not meaningful because there's a factor called perplexity. You read about it basically later on, that with a different perplexity, even the shape of cluster and distance can change. So that can sometimes gives like a wrong picture. So I'm using MDS to just to give you an idea. How does it look like? This is a code for getting MDS embeddings, right? I'm just adding some colors for my 4 classes, my orange for food, green for cars, blue for physics, red for medical. And I'm just going to, let's say, plot those things again, right? So look at, let's say, bird. So bird base is not defined well, but look at sentence bird. See, all colors are in a separate area. So it's, as a space, it's able to do a good job, right? on differentiating between all of these classes. Now let's look at the other ones, right? So let me compare this time with GPT-2 and GPT-3, right? The commercial one. So this is the open source one and one. They also able to classify, as you can see, they were doing decent. But if you look at between these two, so in GPT-3, they said this one orange point came in the area of green, right? So but in GPT-2 did not. So actually we can see here also, right? GPT-2 is better than GPT 3.5, the commercial one, for in terms of differentiation of data, right? But if you compare with this, SBERT is even better. It was more visible in that heat map, but SBERT is kind of doing better. Now, if you look at just quickly the next one, so the medical ones, they are kind of okay with their own class. But for example, here you can see the red ones is separate quite easily, but rest are mixed. So as we expected, they're focused on their domain, not other parts, right? So this is, we could see, this was like one quick understanding that here for embeddings, these encoders, especially sentence encoders, are very powerful. So we need these for precision encoding. So I'll now quickly show you some cases of how we can kind of further increase precision. So I'll quickly pick some data again, right? I have some predefined sentences. I'll just load them for you. So there is some data like talking about sentences, medical issues, like just reading. There is a code for ICD code for that, right? And the humorous definition for that, or ICD definition for this code, right? So I'll pick some more data, right? This is similar diagnosis. These are some tricky cases in nearby, like for example, systolic failure, acute systolic failure, diastolic failure. I'll just go with the technical terms, but they're very nearby and very confusing. So let's see how does the model does on them, defining them, right? There's some similar procedures like Ontologies fusion. They mean the same thing. Like PTCA, coronary angioplasty, they mean the same thing. So we'll use them, right, and see how do they work, right? So I'll load some more models from Hugging Face, right, and kind of divide them into word models and sentence models, right? So one starting with S- sentence models, that's are kind of the word models. I'll just load them, all of them, right? Now let's just, so now I would say there are key ideas over here. So as you know, now we'll go some more details, right? So these vectors are important. So for a fair comparison, you want to have a common ground, right? That they are kind of compared on the right ground. So the vectors, you have multiple options, something called a pooling strategy, right? So just to talk about pooling quickly, what does it mean? So just quickly show over here. So there were some types of things. I think I covered them. That I'll just keep them this time fine tuning, which I covered in examples. There's a list of those things, right? And then they're in context learning, RG. I just showed you examples. And now I'll just talk about this pooling part, right? So in general, given a model like a Butler model, so where the words we get like final pooling. So pooling basically combines them. So actually, when you give 4 words, you get 4 vectors, right? And there are different ways to combine them by pooling there. Like one way, take average time, right? So all these 4 vectors, we get one final vector, that's a mean vector, that's called mean pooling. Then you can add a new token called CLS, right? That is a special token out of the starting of sentence, and you got embedding for that, that's called the CLS pooling. Then there's something called a pooler function, right? Attention applied on top of CLS, right? That gives another embedding. These are like the 3 options that we have. And I'm just going to explore which one is better over here, right? In this piece of code. So these are like functions to get those embeddings, like pooler embedding, CLS embedding, mean embedding, right? And I have a wide distance matrix function, right? So I'll just quickly go through the quick things. This is going to try on data. Like these are the phrases I want to compare. I want to see these are similar phrases. How can we kind of see which is doing better? So I'll do cosine similarity and see which pooling strategy gives me a better cosine similarity. I know these are actually similar, right? So it's just random embedding. So I just apply the function get encoder pooling for the phrase and the alternate phrase, right? It's on the table above. So I can just get the prepare the data, and from that I'll just quickly do a similar thing, right, for the pairs. So what I'll do basically, I'll do the cosine similarity, right, between the 2 pairs, which is basically the phrase and the alternate phrase. So after creating those cosine similarity, let's just quickly look at it. So I'll just print those scores. So these are these scores, which of them, let's just visualize scores would be easier to visualize. So if you look at, let me just plot the visualization. So here in this version, basically what you can see, blue one is the pool vector, orange is CLS, and green is mean. In all the cases, blue is higher. So this means from mean pooling, CLS is better. From CLS, the pool vector is better. And just to you know, as per the authors of BERT, pool vector is like just a tan H activation function on top of the CLS. So that's like one thing, you should use the pool vector, right? effect of tokenizer. I use medicine basically. I'll see how different tokenizer kind of give me a different piece of that. So I use all the encoders and just saw the token version of this, right? So you can see there are different types of tokens done by that. Like if you look at a sentence, some are breaking into very small parts, like breaking the dual, like duodenal into den, u, right? Ulcer into ulcr. So let's just look at the counts. How many tokens do they create, right? And if you look at this chart, so majority create like some 90 tokens from the same sentence, some create only 10. So MS PubMed BERT creates only 10 tokens. And if you look at those things, so the keywords like see in this chronic and hemorrhage and ulcer, they're not broken. So these models which understand medical language did not break the keywords because they're not important. Although it's like a debate that will make a difference if you break it. It won't make a difference if you large data, right? For example, if you have like instead of 10, you have 20 tokens. Now the combinations increase, and now you need to have more data to basically learn the semantics between them. So it gets harder to learn the interrelation between them. So that's why lesser are better. So if you have domain data, you have domain better, right? Domain knowledge kind of tokenize is better for them. So then a quick question about the context. Do we need to do entity action or even sentence enough, right? So an example, I have sentence also the phrase. So basically I extracted the key phrase from this sentence and kind of see which one does better. So in this, I'm just creating the embeddings for basically the sentence and the phrase and description. So idea is basically we'll compare sentence description and we'll compare the phrase description to see which one is basically getting better. This now for the sentence encoder models, right? Earlier one for the encoder only models. So both of them, I'll just do a cosine similarity, right? I'll basically just the distance matrix, the cross dismat for the cosine similarity, and just see and visualize them, right? So let's first visualize the encodings from the sentence one. So look at that. If you can see, like lighter is similarity, dark is not similarity. So some graphs are very dark, right? So mostly are dark. So we're not able to get good similarity over here. See, just to how to interpret these graphs, the idea would be that we want expert diagonal to be highest, right? Because they already paired. So the phrase and the other phrase are diagonal. So if you get highest for diagonal, that's the best case. But here I see a lot of dark areas, right? I don't see that. But if you look at the phrase embeddings, right, which are basically this, so these are still getting something like C.9, 3.95, these are getting better. So in short, do we need sentences or phrase? All the LLMs are smarter, but those extra contexts sometimes dilute information, right? So if you use phrase, that's better. Phrase means entity, so you should do an NER, right? And because they're domain specific, there are many tools, like for medical domains, there are many tools like CARD, all those things for your domain you could have. So I won't go details of how to do interdiction, but yeah, you should do it, right? That is more better. So now talking about the precision part, right? How do we increase precision? So I'll take another sentences where there's also very complex sentence, right? See, they are all heart failures with different types. Systolic heart failure, diastolic. Systolic means like the heart is going down. Diastolic, it's going very fast, right? It could be happening both chronic from a long time. So like for cerebral ablation is different course, right? So now this is a complex scenario, how these model perform over here. So again, I'll quickly just get the embeddings for phrase description. This time we won't do sentence because we know sentence is not useful, right? Only the phrase is useful. So we'll do both for the sentence models and the word models, right? And I'll just come to distance metrics and then just visualize them, right? So here, so I'm getting some scores here, right? Like for these different complex sentences. So it is not easy to understand them, right? Because there are lots of numbers over here. Let me just highlight the maximums, right? So that it's easier for you guys to focus on the key things. So I'll write a small function to kind of just visualize them. So now you see the boxes, right? So green is the max of them. As you can see, it's not diagonal, right? So we want to use the diagonal as a best one. Some cases are like here we have 4 on diagonal, but not too good, right? So we can increase that. So we can do a simple thing. Let's say if we just kind of clean them, right? So in the data, there was some extra words like negative was like unspecified, unknown. They are not adding. They basically means absent. So remove those words and those bracket words, right? And then regenerate the embeddings like some pre-processing we're doing. So I'm just rushing a bit because we're short on time. So I'll just show you the results of this. So just I prepared those data again. And now what I'll do, I'll basically come to distance metrics again based on that and quickly show you the results with the max. So now if you see now we got a diagonal, right? So with basis cleanings and things, we can precision. So with some like all these techniques on the left side, you can increase precision. And on the final part quickly as a wrapper. So this is where we can get to ontology, right? These vectors can give me an insight like ontology, right? They said trio, right? Disease or different system, then heart failure, it goes long. So I can have the VC categories over there. Those codes are part of this tree. So what we can do is basically we can use these anchors into this graph. And like, for example, the same things over here are part of graphs. I can get anchored to a graph, browse it, and kind of get to precise one. So in short, we can combine first the sentence encoding to get to a topic, then use word embeddings to get to a precise thing, get a precise code. With this, I'll give it a stop. And yeah, I'll conclude this. Thank you very much.